All right, hello and welcome to the next episode of 3Din30. Today we're going to be talking about AMUG, or the Additive Manufacturing Users Group. So AMUG is a bit of a combination of different things. It's kind of like a part conference, part educational environment, part trade show a little bit. But it is definitely unlike any other show that you go to. It tends to be a community where engineers openly discuss their issues and solicit feedback, and just amazing opportunity if you're in the additive manufacturing community. One of the cool things about the show is if you go to it, you'll hear Hollywood, I don't know, employees, I was gonna say producers, but I don't know that they're all producers, but you'll see people active in the Hollywood community talking about how 3D printing is affecting their products, companies like Leica, all the way to companies launching space vehicles into orbit, companies like Launcher. And so it's an amazing opportunity to just see that whole range. To give you another little bit of color, the main accolade, the main achievement you can get at AMUG is to be called a dinosaur. So you call them dinos. And we've had a couple dinos on the show. We've actually had a keynote speaker that will be at the next session on the show on the 3Din30. So we have a pretty good track record when it comes to AMUG people. This year AMUG will be in Chicago. No real surprise there. It'll be from March 19th to the 23rd if you're interested in going. So it's coming up very soon, which is why we're doing this show now. And one other thing to kind of look at is if you look at the past attendance for AMUG, and you kind of take out this little postponed section, which we all know what that was about. AMUG looks like it might be a record attendance this year. So one of the biggest shows, if not the biggest, in the history of Additive Manufacturing User Group. So an amazing opportunity to get in there and learn more about 3D printing. As I mentioned, kind of one of the keynote speakers will be our own Max Hout from Launcher. He was on a 3Din30 a couple months ago. They recently got acquired by Vast. And one of the Diamond sponsors is a company called GoEngineer, and they're going to be here today joining us. So we're bringing on our guests. All right. This is Josh Brown, Director of Metal Additive Manufacturing, and I'm going to bring on Tyler. So this is Tyler Reid, Technical Director, Digital Manufacturing, and we're going to talk about AMUG 2023 and specifically what GoEngineer and Velo3D have in store for attendees this year. So my name is Mike Rogerson. I'll be your host today as we talk about an AMUG preview with GoEngineer. As a reminder, this is a live show. We'd love to hear from the audience. Some of you get in questions like the very first word out of our mouth, so I'd love to see that. Keep in mind, there's a little bit of a delay between when we see the question or when you send the question and we actually see it. So kind of give us a little bit of time on that, but we'll definitely get to those as soon as we can. So let's start. Tyler, can you give us a little bit of background about yourself for those who don't know you?
Sure. So my name is Tyler Reid, and I've been in the additive manufacturing reseller channel since 2010. What that means is for the past 12 years, I've been handling the technical side of the conversation around companies finding value in professional level 3D printers, both plastics and metals.
Nice. Josh, a little bit about you.
Yeah, like Tyler, I've been in the additive space for 10 plus years now. And those years range from polymers to metals, just like Tyler, with the last 5 or 6 years focusing primarily on metals, and the last 2 years being here at GoEngineer.
Fantastic. And both of you have been to AMUG, is that correct?
That is correct, yeah.
Fantastic. So, Josh, maybe what are your impressions of the show?
I've been to AMUG 5 or 6 times, Mike. And like your chart showed, it seems like every year I go to AMUG, there's more and more people, it's a testament to the industry of its growth and where it's going, which is exciting to see. I love going to AMUG because it is different from other conferences that we have in the additive space, because it's for the users. And so you get a part of a little bit of a trade show aspect, but most of it is education and learning about what's going on from current users, which is something I really appreciate about AMUG.
Yeah, I learned just how much post-processing can really affect this, and it's just that whole ecosystem. Not just the printing of the parts, but you just have everything else that goes into it. So definitely pick up things. Tyler, what do you like most about this format for AMUG?
Well, I do like that it's focused on the users. Within this industry, we are hundreds, thousands of people who are using advanced tools, and we've all kind of had our own circuitous route to the knowledge that we have and the experience that we have. And it's very siloed, globally, really. And AMUG seems to be the one week of the year where we all get in the same place and let our guards down. We're less competitive with each other and share secrets with each other. And especially if you can kind of step out of your naturally introverted self and talk to people, you come away out of that week with some really valuable knowledge.
Yeah, and you kind of hit on the people who are attending. Can anybody attend AMUG, or is it like certain types of people can attend? What's the audience?
So I think historically it's been you have to be a operator or a user of what a commercial level or professional level 3D printer.
Okay, so you have to be kind of in the club. You got to be a user then. I guess that makes sense.
Exactly.
Awesome. All right, Josh, let's change gears a little bit. Can you give us some history or some background of GoEngineer?
Yeah, absolutely. GoEngineer has been around for 25 plus years, and GoEngineer really got its roots on the software side of the business. GoEngineer currently is the largest SolidWorks reseller in the United States. And with that, GoEngineer has a hardware division that both Tyler and I work in that support 3D printing, covering Stratasys all the way to Velo 3D. And so we combine both the software side and the hardware side to service our customers across the U.S.
I mean, it seems interesting that you have software and hardware. Do you see synergies between the two?
Absolutely. I mean, a lot of our users are utilizing our software to design parts that go on our printers. And so it actually, there's a lot of synergies between the software side of our business and the hardware side of our business.
Oh, interesting. And I think you recently had an acquisition, something in the news, right?
We did. Yeah, we recently acquired a company called CATI, which had some roots on the East Coast of the United States. That acquisition was finalized at the end of last year. That team has been fully integrated into the GoEngineer family, which really has doubled the size of our company, Mike, both in terms of coverage, personnel, and everything that comes with that. So it's an exciting time to be at GoEngineer.
So you mentioned kind of like the East Coast, you're doubling. So are you mainly a U.S. focused organization, or is there an international level to it?
Primarily U.S. We do go into Canada in some regions, but yeah, U.S. and some of Canada is what I would say.
Awesome. Well, thank you. So let's talk a little bit about AMUG. Tyler, what do people have in store when they show up to AMUG with regard to GoEngineer?
Well, GoEngineer will show up in force this year. Thanks to that incoming team from CATI, they've been headquartered in Chicago, so AMUG was always a local show to them, and they always had a really strong presence. And so we are kind of jumping off their lead there. We've got a big booth, we've got a ton of different machines, and a lot of parts to show everyone. And we've got post-processing machines, printers, etc., tons of software, 3D scanners. It's gonna be little games and giveaways and stuff, but it's really focused on the users. It's during March Madness. We've got a couple things in store there as well.
Sounds pretty awesome. What about some of the technical sessions? I understand that, like, from what I've been, a lot of focus is on the technical sessions themselves.
Yeah, so we are involved in 4 technical sessions, I believe, ranging from some hands-on workshops. We have one called Snap, Crackle, Pop, where instead of just looking at the spec sheet for materials, we actually printed a bunch of different parts. You can get a feel for how the different materials, plastics mostly in this case, perform, for example. And then on Wednesday, I am fortunate enough to be joined by Brent Hansen at Velo to talk a little bit about what the journey towards scaling metal additive manufacturing looks like. What the current state is from our perspective, what the last 10 years has been from our perspective. And again, you're in front of your peers, so we're looking forward to a conversation around that topic.
Can you give us a bit of a sneak peek of what you'll be talking about?
Sure. From my perspective, I think metal additive manufacturing's adoption has trailed expectations over the last 10 to 15 years. There have been some serious challenges towards scaling into production uh, in terms of both volume, which a lot of people are familiar with, but also quality control, quality assurance, and also the usability of the workflow. And so we'll be talking a little bit about each one of those, what's Velo's plan around those specifically, and really looking forward to that conversation.
Nice. So, Josh, you've been in the industry, I think you said like 10 years. What's your view on scale and the challenges of scale?
It's interesting, Mike, that even as we kind of talk about what we call some of the outside resources that companies use to scale in additive manufacturing, initially we used to call them service bureaus that did a lot of prototyping for companies. And now we've even changed that terminology now to contract manufacturers, right? And so within that, we've kind of taken this step to where we've grown out of prototyping and we're looking for production partners, way to scale, internal resources to the broader masses. But with that come a number of challenges. When you're looking at additive manufacturing, you're looking at reliability, you're looking at machine-to-machine consistency, and then quality are just a couple to name a few. And so that's really been one of the challenges that I've seen personally as people have tried to scale, is finding reliable resources outside of their own company to help grow that. And so it's been interesting to see how Velo really has kind of taken a different approach to production additive, and really how that's helping fast track a lot of these companies to scaling.
Yeah, I've seen, or just in the last year, companies are able to either internally take on additive, and we've seen history, for the last 30 years, companies doing that. They may be able to qualify one contract manufacturer, to kind of use your language, or service bureau, but then getting more than one and getting multi-supplier scaling. It seems like that's kind of where we are in the industry, and there's just a huge barrier to entry there. Tyler, have you seen any evidence of that, or what's been your experience on getting multi-supplier scaling opened up for additive?
I have seen evidence of that. It's a really interesting scenario that so many people that we talk to find themselves in. These are people who have built up business cases, designed parts, begin manufacturing parts, specifically additive parts that customers want, large OEM customers want, but they want them at a scale that honestly, there's not enough printers installed in the US to meet that demand, let alone fill the parts with them. One of the issues there is that whoever the owner operator was, or whoever the technician or the additive engineer was that figured out how to make it work on the one machine and then on a second machine, they can't do that for the 5th, the 10th, the 30th, the 100th machine. Their time and their skills don't scale. So there's this pent up demand for additive parts that you just cannot access because the workflow to get there just isn't scalable.
Yeah, there's a great chart, and I can't mention who it's from, but I'll kind of give you a brief idea. And it has on the one axis how many parts you need per year. So the typical thing where AM makes smaller quantities versus larger quantities. And it kind of has AM in the lower section. And then it has part complexity on the other axis. And it's really interesting because they kind of go through and you change your manufacturing platform, you change your manufacturing technology as you move to the right in that chart. And there's normal things like kind of stamping, molding, you've got die casting or CNC machining. And then now there's this new category where additive shows up again. So it's like there's a low quantity, what we mentioned actually is prototyping market. And now far on the right, now additive comes in, but there's nothing above it. There's nothing to create a ceiling. So it's not like low quantity, large, small quantity, large quantity anymore. Now it's small quantity and large quantity both met by additive. And I think that's what we've seen, these complex parts, there's no ceiling there. The production could be limitless, could be whatever number you want. There's just no other way to make it. But then as you try to scale up and get more than one supplier, now you're stuck. So it's an interesting conundrum.
It is interesting, and I think that it's unknown to a lot of people. I think the casual user looks at a chart like that and assumes that the limitations are based on the hardware. The limitations are based on the actual capabilities of how much powder or how much plastic is pushed through a machine. But the reality is that a lot of that scaling challenge is from the usability side. It's on the software side that can complement the hardware side.
Yeah, and we've got kind of a picture of one of these parts here. Maybe you can give us a little bit of background about what we're looking at now.
Yeah, so these are choke valve trims from a company called IMI. And these are redesigns of existing components that are intended to increase performance of the valve and also increase things like reliability. The interesting thing about these is that, of course, they're monolithic prints. You're seeing two main prints there along with the tensile bars and things like that. But those two main prints replace up to hundreds of individual components that in the past would have been stamped or lasered, little thin discs that are then stacked in a precise order and a precise orientation and then brazed together. And additive manufacturing allows someone to design for performance first and foremost, eliminate all of the clutter in your bill of materials, and produce something that's reliable on the scale of onesie twosies like that. But as you move over to bigger machines with more lasers, then you can scale that up to higher volumes.
Yeah, that's actually, let's talk about bigger machines for a little bit. Josh, we'll switch over to you. So, larger machines affecting the market. What do you think is going to happen with these larger machines?
I think that's the direction that so many companies want to take metal additive is larger machines. And it's not just due to larger parts, Mike. It's also due to higher throughput. As we continue to add lasers to these systems, the throughput increases dramatically. So we're seeing a lot of companies look at larger systems to increase that throughput so that they can scale to production. And with the Velo Sapphire XC, it's the exact direction that so many of our companies that we talk to want to go.
Yeah, it's pretty powerful. And that large one with the 8 lasers versus, you have this legacy system with 1 laser. I know the Sapphire is 2, Sapphire XC has 8. That's not easy. You can't just add more lasers and expect it to work. So what are some of the challenges engineers might run into? And maybe Tyler, this is back to you, on running multi-laser systems.
Well, every time you and I have talked about this, Mike, I try to come up with a different analogy for the complexity of this problem.
I like the sports one. I thought the sports one was good.
Okay, we'll stick with sports. So, we know the difficulty of choreographing people on a football field, right? Football field has 24 players on it at any given time. And in the past, you would have coaches reviewing tapes after a game and trying to ensure that everything that they tried to choreograph on the field actually played out. And if you look at the sidelines in an NFL game, there's almost as many coaches as there are players, because choreographing, complex situations in real time is difficult. And so for so long, like with legacy machines, you have tapes and you review the tapes on the back end and you're trying to figure out, did it do what you want it to do? Nowadays, when you're watching, like if you're watching Thursday Night Football on Amazon, the cameras pick up the players. They know exactly where the players are. They know exactly where the positions are, and they can feed real-time data to the coaches. And so choreographing all of that is only possible if you have data, and the time that you get to your answer is dependent on the data. So one thing that Velo has done amazingly well, in addition to just adding lasers, is making sure that the lasers are feeding and the hardware is feeding enough data to the users in real time to ensure that the choreography is successful. As you add lasers, you add more heat, more energy. You add more stitch lines, which are a nightmare in terms of quality control. They can be a nightmare, potentially. We've grown accustomed to assuming they're a nightmare because that's historically what it's been. But there are many challenges. And so there's like this joke about adding more lasers is just like throwing, coal on a fire. But I think Velo's doing a great job of dispelling that myth.
Awesome. Yeah, you kind of mentioned just the larger parts, no stitch lines. Here's your comparison. On the left, you got a Sapphire XC impeller. On the right, you've got the standard Sapphire 315 millimeter build plate with an impeller full size. And we're not even using the full build plate for the one on the left for the XC. But if you get a chance to look at these parts at the trade shows, Tyler, to your point, there it's impossible to tell this was done with 8 lasers. It's pretty amazing that is invisible. Like there's just no lines there.
Yeah, I mean, it is amazing. The size and scope of those parts are just impossible to tell over the web. So hopefully, people viewing this will be in Chicago to see those parts and parts like them in person, because they are very impressive. They are very impressive.
Nice. So, we kind of talked about larger systems. There's also sort of this element of new materials. And, we talked about the additive market growing and expanding. And from what I've seen, like every time we launch a new material, it just opens up a new market for us. One of these we launched not too long ago was M300 for the tooling market. And that's been pretty amazing. But Josh, I kind of wanted to get your thoughts on that. Where do you see the mix with additive and tooling and two things that you wouldn't think would go together, but they seem to go together pretty well?
Yeah, I mean, absolutely, Mike. Me and Tyler were just in Detroit last week for a Velo GoEngineer Roadshow. And the amount of interest that we had just in that M300 material combined with a Velo system really was through the roof in terms of interest and people wanting to utilize that type of material with your system, Mike. And so I think as we look at industries like automotive that maybe seemed out of reach initially for additive, bringing in new materials like this M300 and opening up applications like tooling is really going to help expand really the user base for Metal AM, but also help a lot of these customers that have had challenges with tooling in the past.
Yeah. And so like you think additive, think these inserts, and Tyler, what are they using additive for? Like how are they using AM and for an insert?
Yeah, the interesting thing about the tooling discussion is that it's a different route to access scalability. Accessing scale isn't just about producing printed end parts. It's about inserting the technology into workflows that eventually lead to scale. And that's where tooling has a huge advantage. The scale of tooling is largely dependent on the cycle times and the quality of the parts coming out of the tools. So additive affects both cycle time and quality by opening up the door to this thing called conformal cooling. These tools, let's say high pressure die cast tools, for example, have molten metal pushed into them at extreme temperatures, pressures, speeds. And as the material solidifies and cools and you pop the part out, you evaluate if it's good or not, and how quickly you can iterate that has to do with your scalability. And there's a limit to how fast you can do it because you can only cool so quickly. So if you do it too fast, then you start to scrap parts. But with conformal cooling, which long story short, allows people to cool it more evenly and more aggressively, you can reduce cycle time for one, without negatively impacting the quality. And in fact, in most cases that I've seen in research, reducing the scrap rates. So although the tool may have a nominal cost higher than a conventionally made tool, the ROI on that is nearly instant in many cases, especially say automotive. We were in Detroit where the cycles count for these tools are hundreds of thousands of tools. So over the lifespan of a tool, I mean, it pays for itself over and over and over and over.
That's pretty awesome. I mean, it kind of begs the question, like here's a market where you've got additive affecting conventional, and we find this synergy again. Are there other markets that are just out there ready to just absorb additive into a conventional manufacturing strategy?
Yes, absolutely. It is a matter of passing through all of the gates correctly. And that's the road that additive has been on, since its very beginning, is what gates can we pass through based on the current state of the technology, the current state of the usability, etc. More and more we are seeing 3D printed parts in the fashion world, for example, which I would have never guessed.
Yeah.
But one
not
of the
so
nice
much
things,
metal, not too many
not
metal
yet,
parts there.
not yet, but there's one or two gates that they have to get through to get to that
Yeah.
point. Additive manufacturing in general is democratizing. Anyone can pick it up and begin making parts at a certain point. And so because it's so accessible, it's exposed to a lot of different problems. And the OEMs are constantly trying to just prioritize what problems to fix. And we're moving very rapidly. There's still a lot more problems, a lot more gates to get through.
Yeah, no, just another example of where additive is not really replacing anything. It's complementary. Like, you make a part, you print it. I think we put up this part earlier. Like, you can't use this part in this manner. You've got to take it, cut it off the build plate. You got to finish machining it. So all of those conventional processes for post-processing, they're still is valid. They're still extremely important. And it's just another case where the two actually go together a lot more than you'd think. They're not really enemies. They're sort of frenemies.
Yeah. I mean, certainly we're doing a lot of heat treat and a lot of machining and post-processing. We're selling fewer nuts and bolts. We're selling fewer brazing rods and things like that. So, you're not replacing anything. You're optimizing.
Yeah, it's pretty awesome. So what are the other materials, kind of before we come up on the half an hour mark here, is copper. Like we sent a ton of interest in copper. I don't know, Josh, what's your take on the copper market with additive? What's driving that?
Yeah, I mean, I've been engaging with customers, Mike, that have had interest in copper for years, and it seems like just recently have companies like Velo figured out how to process this material and do it effectively, and do it in a manner that meets the requirements of the customers for those end use parts. So with that being said, and kind of that code being cracked in how to process copper, we're seeing a lot of demand with companies that really want to go into production with this material. So there are so many use cases for copper and just what it does as an alloy, that there's a lot of companies that want to open up new applications, what were previously, again, out of reach. But now that there's a material that's available to kind of achieve the things that they need to do, additive becomes a viable tool in that manufacturing. So we're seeing a lot of interest in copper.
Yeah, you hit on some of those challenges. Like these are used for heat exchange applications, and you're shooting it with a laser. I know, just talking with some of our engineers, you put energy in, that energy moves. It moves so much faster through copper than it does through other materials. And the melting point for something like GRCOP 42 is so high that you have to put in more energy in it, and it's moving faster. So like the technical challenges are definitely there. And then you have all that residual heat in the chamber that you've got to deal with. So yeah, definitely real challenges that we're facing there. So we're almost up on the half an hour mark here. I do want to kind of get a couple closing thoughts. But real quick, if people are not able to attend and they're not operating a system, but maybe they want to operate a system in the future, what's the best way to learn more about GoEngineer, about Velo 3D, and getting in contact with you, Josh?
Yeah, you can reach out to Tyler or myself via goengineer.com. It's a good way and an easy way to access us. Also look for our GoEngineer road shows that'll be popping up around the US this year. We're going to be, showcasing Velo 3D. But yeah, reach out to Tyler or I, or goengineer.com is a great way to find us.
And you mentioned you just completed a roadshow in Detroit. What do people see at these roadshows? What's kind of the big draw?
I'll let Tyler handle that. He was the main presenter of the show in Detroit.
Well, you get hands-on with the parts first and foremost, and it's not every day that you get to hold, exquisite copper printed parts. So that's a fun component of this. It's very technically oriented, so there's a lot of technical discussion around the hardware, the software, the workflow. It's a great place to ask questions and hopefully receive good answers. When we do the road shows, we always have a team of Velo engineers there to help. They're our call a friend, phone a friend when I don't know the answer to a question. And for the ones that are hosted in our offices, you get hands-on time with all of our plastic printers as well. This last one in Detroit, we probably had a dozen, high-end 3D printers running while the show's going, that represent a half dozen different types of technologies, which we take for granted because we work in these environments every single day, but most people don't. So we love to do show and tell too.
Awesome. Well, thank you very much for your time. I know we're definitely up right now in our audience. Thank you for joining us as always. Hopefully we'll see you all at AMUG in, I guess, about a week now. So thank you for joining us. And Tyler and John,